Okay, let's talk about finishing up section 4.1, and we want to write a quadratic function in vertex form. Well, remember, if it's vertex form, you're probably going to have a vertex. So let's take a look at our vertex. We usually have our vertex set up as some form of xy, and remember, that is really hk when you're working in the standard form. So we're working with a vertex in standard form. Later we're going to talk about going from standard form to vertex form. And the big part about both those ideas is that we need to first identify that vertex. So let's take a look here. This is a picture of a jumping dolphin, and I wanted to show you a video of Jim Carrey as the dolphin trainer in Pet Detective, but we're short on time. Maybe we'll do that in class. So let's take a look at this picture here. They want us to go ahead and write a quadratic function that models the path of the dolphin's jump. So here is the path of the jump, and they want us to write a model from it. Well, we said the first thing we might want to find out is the vertex. And as a matter of fact, if we go to 3, 7, we can find out that is the maximum height of the dolphin. And let's take a look at that standard form, see what they did. They went ahead and identified that we need to find A, H, and K for this standard form. So we know H and K because that's our vertex, H, K. So they plugged in 3, 7 into our format, 3, 7. Now we were left with finding A. Well, that's the only variable left, so we're actually just going to go ahead and simplify here. Solve for A. 9 minus 3 is 6. 6 squared is 36. A plus 7 equals 4. Subtract 7, and then divide both sides by 36, and you're going to have negative 1/12 is your A value. So now we've got f of x, which we know is y, equals A times x minus h whole thing squared plus k. And that is our model for the jump of that dolphin. Again, all we needed to find out was the vertex. Plug that in, and then plug in 4 and 9. You're asking yourself, where'd you get 4 and 9? If you take a look here, or 9 and 4, I should say, where did you find 9 and 4? Well, if you go down the path here, you go over to 9 and then 4, you can see that was another coordinate on the graph. So all we did was just plug in HK, and then for X and Y, we plugged in 9 and 4. I'm not sure I explained that well the first time, but all we had to do was just plug in HK, X and our Y from another point, and X and a Y from our another point. Our X was 9, and our Y was 4. 9 for X, 4 for Y. Plug those in, and all we had to do was just solve for A, which we did here. Let's move on to section 4.2, and we're going to use our graphing calculator here. So if you have one, that'd be great to get that out. I'm going to get mine out here, and hopefully you guys can see the whole screen there. I think you can. So let's take a look at our first question. In section 4.2, they want us to go ahead and go from standard form, or look at the standard form of a quadratic function. Well, as we know, the standard form is right here. Y equals ax squared plus bx equals, sorry, that should be plus c. Typo. This is the standard form of any quadratic equation. The values a, b, and c tell us key information about the function in the graph. So let's talk about first finding our features in a quadratic function. We'll use a calculator for this one. Get that back up here. And it says, what are the vertex, the axis of symmetry, and the maximum or minimum values, and the range for y equals 3x squared minus 5x plus 1. So I'm going to go ahead and turn my calculator on here. Hopefully that will work. Sorry for the technical difficulties there. Let's go ahead and plug in our quadratic equation. 3x squared minus 5x plus 1. And if you're wondering where I got that squared value, it's this x squared button right here. So since we're just graphing a linear or a quadratic function, make sure your plot one is off, and it's probably best to go to just zoom 6 and take a look at your nice little pretty graph here. And it does print really slow, doesn't it? We'll get around that here in a second. Do me a favor, go to Window and scroll down to where it says XRes on your calculator, and probably just make that a 7, and then regraph that, and you'll see how much faster it is. Lo and behold, there it is. Now, when you change the resolution on your screen, it has a tendency to get a little funky with the graph. Can you kind of see how it went from a smoother graph to some kind of jacked up little V graph? Well, that's what happens when you have a resolution of 7. The graph is faster, but not as pretty. So let's just go down there and let's just make our resolution, I don't know, 3, and see if it speeds up and makes it a little bit clearer. There we go. A little bit sped up and a little bit more clear. So now the question again is, what is the vertex, axis of symmetry, maximum or minimum value, and the range of this function? Well, the way to find out the vertex is to say, wait a minute, is this a minimum value or a maximum value? Well, since it's concave up, that means it's going to be a minimum value. So as usual, we go to Second Calc, and we're going to go find the minimum, because we're looking for the minimum of that function. Hit 0, or hit Enter. And the calculator asks you a couple questions. One, is this cursor to the left of your point of interest? The answer is yes, so you hit Enter. It now asks you, is your cursor to the right of your point of interest? No, so then scroll that over there. Now go ahead and hit Enter. And if you've noticed, you'll see that two little triangles have come up on your computer, on your graphing calculator, and it's going to evaluate the minimum value between those two little points. So it's probably going to go down here and evaluate that minimum when we hit Enter for guess. Lo and behold, I have the minimum because it says minimum right here. So you would probably want to round to 2 decimal places, 0.83, comma 1.08, make it negative. 0.83, comma negative 1. I think it was 08. Yes, it is. Okay. So that would be our vertex. Now, the axis of symmetry, as you know, is your h value, right? Remember, these are still h and k. So our axis of symmetry, we're going to abbreviate that now to AOS. And that's going to be x equals your h value here of 0.83. The maximum or minimum value is similar to the vertex, but it is not the vertex. What they are asking is, what is the maximum or minimum output of this function? Remember, output is always associated with your y value. So my minimum output, remember this was a minimum, was y equals negative 1.08. It is always the value here for your vertex. That is either your maximum or minimum output. Do not put down the coordinate. That is not what we want. We want the minimum output or maximum output. Now we want to take a look at the range. And the range is all the possible y outputs. Well, let's take a look here. We can put any number in for x, so we know our domain is going to be all real numbers. However, the output, your y values, has a certain limitation on it. As a matter of fact, the lowest it can go is what? That's right, negative 1.08. So the range, the y outputs have to be greater than or equal to negative 1.08. So we've got our vertex, we've got our axis of symmetry, we've got the minimum, and we've got the range. And we have solved this completely. Let's take a look at another one. Here, they're giving us an idea of how to do it by hand. In other words, non-calculator active. Please read through this. It is a lot. However, this is the most important part of this picture. What it is telling you is that you can find out your x value and y value for your vertex, in other words, h and k, by using a little bit of algebra. Let's take a look at that little bit of algebra in action. So if we're looking for hk, because you always want to find the vertex, I first want to take a look at how to find that vertex. We've got this handy-dandy little quadratic here. Remember, that's going to be 1x squared plus 2x plus 3. They want us to graph this. First, we need to find the vertex. Remember, our values are a, b, and c that they gave us. That is from the standard form of a quadratic. We just found our a, b, and c values. Now let's take these ideas here that says my x value for my vertex, or also known as h, is going to be negative b over 2a. And what I'm going to do is I'm going to take this value and then plug it into the function. Remember that function notation that we've been practicing. All this is saying is find x, whatever that is, plug that into the function. Here is our function, and it'll spit out the y value, in this case the k value for your vertex. So let's take a look at what all this gobbledygook looks like. We're going to take negative b over 2 times whatever a is, which is 1. And that's going to equal our x value, or in other words, h for our vertex. And we're going to have negative 2 divided by 2, and x is going to equal negative 1. So our vertex already has a value of negative 1, comma, and we're going to plug this back in to the function, which makes sense because you always have your x values as your input, and now we're looking for the y output. So I'm going to plug this back into the function. Simplify. Let me make that a little bit more clear. Simplify, that's going to be negative 1 plus 3. And my vertex is going to be negative 1, 2. That is going to be my hk. So I'm going to go to negative 1, 2. A little bit of math magic here. We found our vertex. Now the kicker is to find another point on this graph. Well, one easy point to always find is the y-intercept. So to do that, plug in 0 for x to find the y-intercept. In this case, it's 0, 3. So I'm going to go to 0, 3. And if you recall, we get a nice little benefit from this being a quadratic function, is that your mirror image is going to be right across from it and the axis of symmetry. More on this section later. Remember to tune into section 4.2, part 2. Have a good day.